Okay, what we're looking at here is my number one computer that we've officially named Godzilla. The reason you're not really hearing anything as far as what we were doing at this point in time was that we had used a new microphone on the camera and got really busy with our rebuild and just forgot to check the camera. So none of our vocals when making this video came out, so I'm forced to do a voiceover for it. My friend Rico right here is looking at the RAM on this motherboard and was asking me why we're going to go ahead and take it out. He's noticing that we have 32 gigabytes of RAM in there, which should be more than enough for any normal system. He made a comment about Jay 2 cents saying about how much RAM this actually needs, and all due respect to Jay, I think he's great. Fortunately, this is not a gaming computer. This is a scientific computer. So the reason was that we were testing an application for a program called Einstein at Home. They just recently come out with some new CPU applications, and so we decided to give a run on this particular motherboard. It is an i7 6950X 20 core on an ASUS X99 EWS. At first, we only ran with 10 cores, so I really didn't want to do all 20. And it was pretty much a good thing we didn't do that, because it turns out with just 10 work units running, we only ended up having like 2.4 gigabytes of free RAM left. What we discovered was that each CPU work unit was using almost 2 gigabytes or more by themselves, and they were sucking up all the RAM. So this decision was made to go ahead and to remove this RAM and install a larger RAM set. So we're currently taking out the RAM from this system. ASUS boards, the X99 EWS has slightly different DIMMs slots that you install into. There's only one latch that holds it in place. The bottom one is more of an angulated. And so what you see here is my friend Rico has removed all 8 sticks of RAM, and then he's getting ready to install some new G-Skill RAM. He's reading off the specs on this one, and unfortunately I don't have that box with me, but basically he was giving you the latency of what it was, and I apologize, Rico, but he's going to go ahead and install these new sticks of RAM, which will give us a total of 64, so each one of these sticks is 8 gigabytes. One of the things that we did discuss at the time of installing is that as this board only has the one latch, the bottom latch that normally connects the RAM is a little bit different. When you install it, you actually have to install the lower half of the stick of RAM into the DIMM slot at a slight angle. I would say maybe 20 degrees, and you want to kind of angle that in there a little bit and give it a little push, and you will actually hear an audible click as it connects, and then you bring down the top part of the stick of RAM into the latch and lock it in place. And it does take a little bit of getting used to when you first start doing this. Not really seen this with any other motherboards, but for this particular one it does happen. So my friend Rico here, he's going to go ahead and try to install it, but he's not actually hearing the clicks when he tries to do it. So we switch places, and I come over and go ahead and help him out and install it, which is really unfortunate because I really had hoped to be able to record that click as you install the RAM on the lower half of that DIMM slot, and because you can hear it, and that lets you know that it's actually stuck in there. And that's one of the problems we've run into before with these motherboards is in trying to install this RAM. you don't get that stick in there properly, and then when you go to boot, it's not being seen by the motherboard. And then you play with it for a while, and then you finally take out all the RAM, and then you go back in again, and then you hear the click, and you realize that it was just because the RAM was not seated properly. And it's really kind of an irritating thing to have to do when you're doing this. Yes, I know everybody says you should just do 2 sticks at a time and just progress that way. You're right, but we've done this enough times that we just go ahead and do all of them and get it done. And I'm explaining to my friend Rico here about how he has to angle that RAM in there in order to make it seat properly, and unfortunately he wasn't able to do so. Don't get me wrong, Rico's built a lot of computers. He's the one that actually helped me start building these things, but this is a tricky motherboard. I've had 5 of these boards, and when they work great, but when they don't work, it's a pain to figure out why they don't work. So I took over the installation at this point in time and installed all 6. And I'm not really going to let this video go on much further from here. I'm just going to cut to the next part, which is actually booting up the machine and taking a look at the specs on the screen and looking at the system as it runs. Okay, so now what we have here is we've booted up the system, and I'm just going to go ahead and zoom in on this little program that we have here called SIV64X. This is made by Ray. I like this program because it lets me look at all the cores, and it looks at the processor speed, what the clock's at, also shows me how much RAM I have going in there, and what the speed of that RAM is. As you can see here, just by looking at this real quickly, this is booting up. Sorry about that. The start the system up, and off the bat, you can see it's already overclocked itself to 3.47 gigahertz of the RAM. Normally this is 3.2 gigahertz, but it's already overclocked itself up to 3.47, so I didn't actually have to do anything to get it there. Next thing you see is that we're running the iCore at 4.0 gigahertz, and there are 20 of them. What I'm showing you here is I have 4 9A Ti's hybrids in this machine, but since we just rebooted the computer, the memory clock is set for 3.3 gigahertz. So I'm going to have to go ahead and shut down these work units and then use NVIDIA Inspector to overclock the memory. Some people say, well, you could just use the Precision X to do that. I've really found that doesn't work as well. So we're just going to go ahead and use the NVIDIA Inspector to overclock. And this thing is a little more trickier if you've never used it before. It took us a little while to figure it out. So what we're going to do first is I'm just launching a program called Boink, and I'm going to exit that, and that will stop all the work units and stop also the new programs running. The next thing I'm going to do is launching something called Process Lasso, and that's the one that's blinking down there, and that is basically going to restrict how much of a core each work unit can use. So now we're launching the NVIDIA Inspector, and unfortunately you're not really going to be able to see this because I didn't really get back up the zoom on this, but what you do is you go ahead and select each individual GPU and go to the P2 state. And the reason we do P2 state is because the P0 state is normally what you would use when you're gaming, but when you use these GPUs for the scientific programs that we do, NVIDIA actually uses a P2 state, which actually has a lower memory clock. So we use the NVIDIA Inspector to actually increase that memory clock up to the same value as you would see in a P0 state. So I'm individually having to go through, select each GPU, then select the P2 state, increase the memory clock, and then apply the changes. And you have to do that for each card, so I'm doing that 4 times here. So it goes relatively quickly, and then we'll get back to looking at this. But as you can see right now, it does recognize all 8 sticks of RAM, and we have a max of 64 gigabytes of RAM in this system. And now I am relaunching the Point Manager, which oversees the applications. And we will see here, you can actually see now the memory has been increased up to 3.50, and that is in the P2 state. And you can also see, sorry, my friend Rico wanted to know what the 3.52 was. So I'm basically just showing him a couple of things here. You also can see that running on the CPU, we're only using 62% of the GPU at this point in time. That's about it.